The second part here is on depreciation value of an asset. So usually when you buy cars, you buy stuff, these will always be cars will depreciate, like, especially in Singapore. And what we have here is to have a sort of like a formula uh, over here that its value can be modeled by this v equals to 50,000 e to the power of negative kt, where k is a constant. So for such questions, we need to be a little bit careful because k is a constant here. Right, so the value of the car after 12 months is expected to be $40,000. Okay, usually this statement will usually help us find unknown constants. So we have a statement here that will help us find unknown constants, and that will help us find the initial value of the car. So from here, I think the first step is we have v equals to 50,000 e to the power of negative kt. Okay, and we have that after 12 months expected to be 40,000. So at 12 months, $40,000 is equals to 50,000 e to the power of negative k times 12. Okay, from here we're gonna do some quick manipulation. We will have 4 over 5 is equals to e to the power of negative 12k. We will be able to ln both sides, so we ln 4 over 5 equals to ln e of negative 12k. By power law, we know that ln 4 over 5 is simply equals to negative 12k. Okay, because ln e is equals to 1, you use power law to bring it down. And so k would then be equals to negative 1 over 12 times ln 4 over 5. Okay, so from here you will use your calculator, figure that out. Why is there a negative there? Because if you calculate the value of ln 4 over 5, it should give you a negative answer. Alright, and that's why you need to multiply it by another negative answer, such that you get a decimal value in this case. So it will be 0.0.01895. Okay, so pretty small value here. So finding k is just the start. So then we can actually finding the initial value. You don't really have to find k lah, but you're actually going to find k for part 2 in fact. So for part 1 is initial value is when, for initial value, this is when t is equals to 0 because it hasn't started depreciating, right? So at t equals to 0, okay, regardless of k, v is equals to 50,000 of e to the power of negative k times 0, which is just simply $50,000. Right? So therefore, initial value is $50,000. Pretty easy. Okay, so then we have part 2, which is to find the expected value after 2 months. This is where you need actually k. So since we already found k, actually one of the things I like to do is that I will put k in this form. Reasoning is because it's easier to calculate. Yeah. So we want to find the expected value, so that we v equals to 50,000 of e to the power of negative k. So if it's negative k, then that means your k value is 1 over 12 ln. It's going to be a bit confusing, so you may want, I will just use the k value lah. 0.0188595 that I found times 20. Okay, so same thing, you have to use your calculator, calculate it out. Be careful, don't make any careless mistakes. Times 20. Okay, you should get a value here of 34471.16. Okay, I round it off to 2 decimal places because it's so much easier. Now, the third question is a little bit challenging. It asks you to find n, which is the number of months where the value of the car first drops to $20,000. So if it drops below $20,000, that means V must be less than $20,000, and that's why. So it becomes an inequality question actually. So you know that V is 50,000 of e to the power negative kt. We will sub everything in later. Actually, we just sub everything now. So it'll be 0.018595 n. Okay, so instead of t is n because now the time period is actually n months. We're trying to find n here. For inequality questions, how you deal with them is you deal with them similarly to how you solve exponential equations. So over here, this will be 2 over 5. Okay, you can still perform a ln operation on both sides. Oh, where's my n here? 595n less than ln 2 over 5. So you realize it's actually pretty straightforward, okay? And then we will have negative 0.018595n times ln e less than ln 2 over 5, which ln e gives us 1. So we have negative 0.018595n less than ln 2 over 5. So from here, okay, you must apply the laws of inequalities when you're dividing by a negative answer, a negative value. So this will change the sign to a negative value. So it will be ln 2 over 5 divided by negative 0.018595. So you calculate that in your calculator. Okay, you will get 40 n is more than 49.27. So actually, so what does this tell us? That means the n value has to be more than 49.27, and that would mean that the number of months after n months, right? So it shouldn't be after 49 months, because after 49 months, this means that the value has not dropped below 20k. So actually, the answer for n should be the next integer value. Therefore, n is 50. Okay, because it should be an integer value. You cannot really say 49.27 months. Doesn't really make sense. But you say 50 months. Okay, so there's another application of exponential equations in the context of depreciation values of asset. Okay, see ya. Bye bye.